So we've gone over part 1 of 3.4, which is factoring and understanding what is a zero and the basic concepts of solving zeros. But now we have to move on and have there's a sort of a theory or a concept called possible zeros. And possible zeros, there's multiple different ways to get the possible zeros, and one way is by the possible zero rational zeros theory, not theory, formula. So here we have p of x is a polynomial with integer coefficients. All rational roots of a polynomial. So it's only rational roots, no complex. Here is a p over t. So, and what's p over p? P is a factor of the constant term, while q is a factor of the leading coefficient. So remember a constant term if it's ax squared plus ax squared plus bx plus c equals f of x. The constant would be c, stands for constant, while the leading coefficient would be a. So that would be the p and q. So it's factor of the consistent factor rather than just having the numbers. So let's have an example, simple example to start with. Sorry, f of x equals x squared plus x plus 1. It's a really simple example. So let's have the constant, which is 1 in this case. Factors plus or minus. Remember, common mistake that the student will make is the possible factors. You have to remember there's negatives. So it's over. It's still what's positive. What's positive? So that would be what's positive 1 divided by positive 1. That's 1. What's negative 1 divided by positive 1 is negative 1. What's positive 1 divided by negative 1 is negative 1. What's negative 1 divided by positive 1? That would be negative 1. And what's positive 1 divided by negative 1 divided by negative 1? That would be positive 1. So we don't need to repeat it. So the rational zeros or roots, it's zeros in this case, would equal positive negative 1. So remember, it's possible. So after this, what we would normally do, so sort of like the extension would be to actually solve which one would be. So if we have f of x equals x squared plus x plus 1, the same equation, same form, not same form, same function we had before, we'll test this out. So we would use dividing. So remember x minus a form. I talked to in the previous videos, and also previous speakers have mentioned. So x minus a form. So I want to try positive 1 first. So I would do it in the not the long division before, but this form, the 1, all the coefficients. This has to equal 1, 1, 2, 2, 3. So there's a remainder, so that means it's correct. So we have to remove this, change negative 1. 1, 1, 0, 0. That would still be 1. So what does that mean? That means that there are no zeros for this function, for this polynomial, because the remainder, no rational zeros for this function. And what would be another way to do this? Well, another way to do this would be Descartes' rule of signs. Descartes' rule of signs helps you evaluate who the Descartes' rule of signs mostly works with this formula. And so I'm going to cover Descartes' rule of signs in the next video.